This simulation on the left shows the phase behavior for a single component in a pressure volume diagram. Let's look at that diagram. So it's log of pressure versus log of volume, and then on the right is a piston and cylinder arrangement. In this case, we're at this point, the black dot, and so we're at higher density, a liquid phase. And if we have lower density, and if we have, say, vapor-liquid equilibrium in two phases, the lower density, the vapor phase, will be green, and the higher density will be blue. And the point of showing this, we click the box here, if you notice, critical point. The point of showing this pathway is that we can go from point A, say, to point B by going around the critical point, going in the supercritical region. There's no, of course, boundary between these. And we will see that we end up with a vapor, a low density phase, without any phase change. Or we could look at, if we click this box, it shows an alternate pathway where we go from liquid to vapor through the phase envelope. And the volume is represented here on a log scale so that we can see it at these conditions and understand the behavior. So let's go and look at this simulation and see for a single component the pressure volume behavior. So here's the pressure volume diagram, and we can move, and we're showing a suggested pathway, so I can move the points along this pathway, and then the volume, the log of the volume, is reflected in the diagram to the right. I could also move the points where we go through the phase boundary, and we see, of course, in between we have two phases in vapor-liquid equilibrium, and then we're back to liquid. So in one case, went from liquid to vapor with no phase change. In the other case, going through the phase envelope, we see a phase change. And so hopefully this gives a better indication of this idea that there's no sharp demarcation between a liquid, a supercritical fluid, and a vapor. This is a continuous function. And keep in mind, these are log scales, and this is the log of the volume.